Hi, this is Mrs. Clark, and welcome to my video on graphing constant and non-constant rates of change. So in previous videos, we have already discussed how to tell if looking at a table we have a constant rate of change. So we're going to start by doing that as well as graphing these ordered pairs on the graph and kind of trying to see if we notice something that happens when we have a constant rate of change. So first let's graph these points. So I'm going to look at the ordered pairs first, and we're going to use them to make a graph here. So our first ordered pair is -5, -6. So from right here, I can get an ordered pair of -5, -6. This is my x-axis. This is my y-axis. So we're going to graph all of these points on this graph. -5 will be 6, -5, -6 will go this way. Left 5, 1, 2, 3, 4, 5, and down 1, 2, 3, 4, 5, 6. And that's going to be our first point right there. The second point is going to be -1, 0. So that means I'm going to go to the left 1, and I'm not going to go up or down at all. I'm going to stay where I am because it's 0. So my second point is going to go right there. Next I've got 1, 3, so I'm going to go to the right 1 and up 3, make a point. And then I've got 3, 6, so to the right 3, up 1, 2, 3, 4, 5, 6, always starting at the origin, my 0, 0 when I start counting. And 5, 9 is our last one, so from 0, 0, 1, 2, 3, 4, 5, and up 1, 2, 3, 4, 5, 6, 7, 8, 9. Alright, so here's our points. If you notice, they do actually make a pattern, which we know of as a line. So we can say these points make a straight line. So I'm going to use a straight edge. I'm just going to use the side of this notepad here to actually connect these points and make a straight line. You can use side of your notebook or ruler if you have one. Put arrows on the end and make this line. And I only want to really connect them this way because they are following this pattern of a straight line where they all line up. So now I'm going to look at each of the differences between the independent variable, the x, and the dependent variable, the y, and I'm going to look at that and look at the graph and try to make a comparison. So if I look at the first two pairs of points, if I look from my x's, if I'm going from -5 to -1, that's increasing by 4. So my first difference here is +4. And if I look on the right side, I'm going from -6 to 0. That's also increasing, but this time it's increasing by 6. So if I look at these first 2 points here, this point is going up and to the right to get from one point to the next. So I start at my first point, I go up, and I go to the right. I go up 1, 2, 3, 4, 5, 6 boxes. And I go to the right 1, 2, 3, 4 boxes. So if you notice, the change here, +4, is the same change in the x direction, +4. This change here, +6, is the same change in the y direction, +6. So I can see the differences here are the same thing I can see on the graph. The x goes in the x direction, which is horizontal. The y goes in the y direction, which is vertical. I'm going to look at the next couple pairs here. And if I look here, I have -1 to +1, so that's increasing by 2. 1 to 3 is also increasing by 2, and 3 to 5 is also increasing by 2. So I'm noticing more of a constant difference here. On this side, 0 to 3 is increasing by 3, 3 to 6 is increasing by 3, and 6 to 9 is increasing by 3. So again, a constant difference on this side. If I look between my points, I'll see that to go from the next one, I go up 3 and to the right 2. Then I go up 3 and to the right 2, and again up 3 and to the right 2. So you'll notice again that my x changes, my increases of 2 show up on these horizontal segments, and then my increases of 3, which are my y changes, show up in the vertical segments. So it's almost like they form these stairs. And this almost looks like it's a constant rate of change, but I got to look at it a little more carefully just to make sure. So if I'm looking at the first pair that we have, 6 over 4, we know our rate of change, we do change in y over change in x. So that would be 6, positive 6 over positive 4. If I try to reduce this fraction, I can divide 6 by 2 and I can divide 4 by 2. So if I do that, I will get 6 divided by 2 is 3, 4 divided by 2 is 2. I'll get 3 halves, which is the same as what I see here, change in y over change in x, change in y over x, change in y over x. So in fact, these are all constant rate of change. I just have to reduce this first one to see that they are all actually 3 over 2. And I can actually see that on my graph too. It's almost like from this first point to the second point, it does make the climb of up 3 over 2, and that it makes it twice, up 3 over 2. And so you'll see we have these stairs that kind of follow our line perfectly, and that's what makes this a constant rate of change. So whenever I have a constant rate of change, I notice this line makes a straight line. So I'm going to write up here, constant rate of change. And so whenever that happens, and I have a constant rate of change, the graph is linear. And I'm going to underline just the first 4 letters of linear to remind you that linear means it's in the shape of a straight line. So anytime I have this type of relationship where I have a constant rate of change and it's linear, we're going to be able to make an equation for it. So I'm going to put a note here that says we can make an equation. So if I have something that has a constant rate of change, I'm going to be able to make an equation. We'll learn how to do that, just a few lessons. But we need to know that things that are linear do have an equation. Okay, so I want to look at the second example as well and see what we see happens with this one. So again, I want to compare our differences here, and I also want to graph our points on the line. So let me start by graphing the points. I'm going to start with negative 8, 9. So x and y, my negative 8 up 9. First point's going to be over here. Then negative 7, 6. Negative 7 to the left 7 up 6. It's going to be here. So far, if I connected those two, I'd have a straight line. Negative 1, 5, though, when I look at this one, it's way over here. Those 3 lines clearly do not, 3 points clearly do not make a straight line. Something is off. I either made an error when I graphed it, or maybe this is not a constant rate of change. Next point would be 1, 8. And that's going to be here. And so again, it's even farther off. None of those, except for 2 at a time, will connect to make a straight line. And our last one is a 6, negative 4, which goes way over here. So you'll notice very, very not linear in this situation. So I'm going to go connect each one individually so we can look at the rates of change between each pair of points. Let me do that quickly. I'm going to connect them in order from left to right so I can make sure I have the right pairs of points connected as I go down the table. I'm not going to put any arrows on the end of this one because I don't have any idea what direction the next point is going to go, up, down, because it kind of is not following that pattern that we were seeing in the other one. So the first pair, if I look at my differences, to go from negative 8 to negative 7, it's getting bigger, actually. It's getting closer to 0. So that means it's increasing by 1. On this side, 9 to 6 is decreasing. It's decreasing by 3. If I go on to the next pair, I have -7 to -1, which is increasing by 6. And then 6 down to 5 is decreasing by 1. Then I'm going to look at the next one. I'm going to be increasing again because it's going from -1 to +1. So it's increasing by 2. And then 5 to 8 is now increasing by 3. So notice already, this side is increasing each time. It's not the same number. But over here I've got decreasing, decreasing, increasing. So that should be a big hint that it is not a constant rate of change. And our last pair, 1 to 6 is adding 5. 8 to -4 is decreasing by 12. So I'm going to go through each pair and look at what that looks like on the graph. So I have from this first 2 points, increasing by 1 and decreasing by 3 on the y side. So if I go from left to right, I go down 3 and to the right 1. Down 3 is decreasing, and to the right 1 means it's increasing. So there's our first rate of change on the graph. And down here, actually, I'm going to write change in y over change in x. I'm going to say -3 over +1. For the next one, it's going down 1 and to the right 1, 2, 3, 4, 5, 6. It's going down 1 plus 6. The rate of change here is -1 over 6. So this is -3 whole, and this is 1/6, which is less than 1. So these are definitely not equal. I'm going to even put a not equal to sign in between. And our next one is going up this time. Up 1, 2, 3. To the right 2. So if I look at my rate of change, it's a +3 over 2, which again is not equal. And then the last one is going down 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. To the right 1, 2, 3, 4, 5. And that rate of change is again not going to be equal. It's -12 over +5. If I wanted to check to see if these were all equal, if I wasn't sure, if I'm not super great with fractions, I can actually divide them out. -3 divided by 1, -1 divided by 6, 3 divided by 2, -12 divided by 5, and see that all their decimals aren't going to be the same either. I can also look at the graph. If I see decreasing at one rate and then decreasing at a different rate because it's a different slant, and then increasing and then a bigger decrease, I can look at them all and I can tell right away that it's not linear. So we want to make a note here on this one. This is not a constant rate of change. And then we're going to also make a note that this is not linear. It does not form a line. It forms all these like individual segments. Okay, so that's what I can see from a graph when I'm looking at constant rate of change. And just to recap quickly, anything that is a constant rate of change, I'm going to see this nice beautiful straight line with these little staircases of the same change over time. All the ratios would end up being the same, up 3 over 2, up 3 over 2, up 3 over 2. If I see something like this on my graph, I can know that it's not linear. It means it does not have a constant rate of change. I'm not even going to bother to try to make an equation because I can't, because it's going up and down and up and down. It's definitely not the same. So go ahead and glue this into your notebook, and then you can move on to the next step. Thanks for watching.